Hi guys, my name is Steven Petruzzo, and I'm presenting on my term project called Route Mining for University of Michigan at Dearborn, CIS 566 Software Design Patterns and Architecture class. So some of the program features here are that we can read addresses from an Excel file. We can read any number of addresses from the Excel file. Addresses can have a second address line for apartments, suites, etc. And the addresses in each entry can be on one line, meaning that you do not have to separately input the address, zip code, street, all that stuff. You can just input the address on one line using appropriate commas. We can also validate and correct the address entries. So UPS web application is used to validate and correct the addresses if possible. If the addresses cannot be corrected or validated, an error message is thrown to the user, and it tells the user to please correct the address on that entry line, and then restart the program. We also find the carrier routes for all addresses that we read, and we also find the total deliveries in each of the carrier routes for all carrier routes. The two above features here use a web API called Melissa to get that data. We also generate two different reports here. The first report contains a list of addresses and the carrier routes. The second report contains the list of carrier routes and the total deliveries for each of those carrier routes. Both reports contain contextual informational headers and subheaders. A simple GUI is also implemented to allow the user to interact with the program. Here we display the list of addresses, carrier routes, and total deliveries. We also have 4 different buttons here that allow the user to get the address, run the program, and generate each report. For each button, there is also a checkbox that gets checked and turns green when the button's function has been completed. Demonstration. So I'll go to the demonstration here in Visual Studio. Let me run this. And here we can see the GUI for the program here called Route Mining Program. Here are the 4 buttons that we were talking about to interact with the program. These are the checkboxes that get checked and turn green when the function or feature has been finished executing. And here are the 3 different list boxes, one for the address, one for the carrier route, and one for the total deliveries. So if we were to click Get Excel File Addresses, it'll run. Once it's done, the checkbox will be checked, turn green. It'll display a list of addresses here that have been validated and corrected. We can run the program now. And run the program will give us a carrier routes and the total deliveries here using the Melissa API. So here are the carrier routes. And following that, there are total deliveries. Checkboxes checked in green. From here, we can generate the first report. And once replace it, so I'll click yes. And we can generate the second report. And we'll also replace it. So going to the file location here, we have report 1. And report 1, we have the main header here, which is Excel report 1, addresses and carrier routes. Then we have the 2 subheaders here, which is addresses and carrier routes. And you can see the validated and corrected addresses here, and as well as the carrier routes. Close this, open report 2 now. Report 2, again, has a new header for report 2, also has the subheaders, and here it has the carrier routes and then the total deliveries for those carrier routes. Another feature here is if I was to input a wrong address. So let's say instead of 333 East 11 Mile Road, I'll just put in 333 11 Mile Road. I'll save that, close it. And then, And then in the program GUI, I can get the Excel file addresses again. It's unchecked. And so you can see that it did correct the address there. And then again, you can run the program and generate the reports, and it should generate the same reports as before. Okay, so now the run programs has done, or the program has ran, and the carrier routes and total deliveries have been updated, which are the same. So let me open up that address Excel doc again. Let me put in something completely wrong here that the program will fail at, just to demonstrate that feature. So now when we get Excel file addresses, it will not get the correct address. It'll say address list contains the incorrect address. Please fix addresses at entry 0 before proceeding. And so we will have to go in and fix those addresses. And the reason why is because when you have a small error here, the program doesn't, or the application doesn't know if you mean 333 East 11 Mile Road or if you mean, 334 or 335. So the application makes its best guess, and if it can't find the one correct address, then we throw an exception there. Okay. Continuing on with the presentation here. So the overall design. So the overall design of the route mining project is pretty straightforward. For each function and feature, there's a corresponding class or a collection of classes, and they all belong to a file that implements the feature. For this, as we saw before, Visual Studios along with C# and Windows Forms were used in the development to create the GUI. So here's the read addresses function. So the class diagram on the left here in figure 1 shows how the class is implemented to read the addresses. This feature and all related classes are in one file called addresses.cs. And real quick, for this feature, we use the adapter pattern to implement it. We'll talk more about the design patterns later in the presentation. To validate and correct the addresses, we have this class diagram here on the left in figure 2, and all the classes and the feature is located under address validate ups.cs. Here's a carrier route feature in figure 3 here on the left. And again, all this feature is completely composed in the route carrier.cs file. And for this, the singleton design pattern was used. Here's a total deliveries feature. Again, everything related to total deliveries is in the total deliveries.cs file, and the singleton pattern was also used here. The generate reports feature here, this is the feature that generates both report 1 and report 2. All these classes here are found in the report.cs file, and the builder design pattern was used to implement this feature. Again, more information on that later on. So showing that real quick in Visual Studios here, we can see that under address validate UPS, this contains all the classes and all the methods to validate the addresses and correct the addresses. Here we just have one class called address validation UPS. And here we have a method called address parse, which parses the input addresses into the correct form that the UPS API needs them in. And here we have the actual method that validates the addresses. Here we create a request, and then here we put in our address and make the actual request here to the UPS API. And here we parse the request and correct the address here based on the response from the API here. Here's the root carrier.cs. So this file gets the root carrier for the address here. Here's that the one class here to get the root carrier. And again, we are implementing the singleton, and here's the instance class. Or here's the instance method. Again, we parse the address from the Excel file list that we read them in. We also we have a method to get the zip code. And here is where we actually request to get the root carrier using the Melissa API. So yeah, we do parse the address, and we do also get the zip code. And then here we combine it into one HTTP URL to make the request. Here we get the response. Here we're converting the response into a JSON by deserializing it. And here we're actually adding the carrier route to the list here. Total deliveries, same thing pretty much as root carrier, except we're getting the total deliveries now. Here's one total deliveries class, again using singleton. And here's the actual method to get the total deliveries here. Again, we make our response using this URL that we create here with the zip code from before in the root carriers. We get the response back and we format it into JSON. And we look at the response and find the correct root carrier and then add the total deliveries here in our list. Addresses. So this reads the addresses from the Excel file, and this uses the adapter design pattern here. So there are multiple classes in this file. More to talk about this later, but here's the actual Excel adapter that actually reads the Excel file and gets the information from the Excel file. So here we're opening and creating a workbook and worksheet. And here we're traversing through the Excel file, and if it contains information, then we add that to our list of addresses here. In the report, this is where the reports are generated, report 1 and report 2, and this is again using the builder design pattern here. So we have our main product here report. We also create the report here. using Excel. And this is the same for both reports. And because the construction here is the same, the builder pattern was suitable for both reports here. And again, here's a concrete um, builders here, Excel report 2 there. And here's our actual director to actually build and construct the report. And both reports are constructed the same. Okay, so that was an overview of the design. So now I'll talk about the design patterns used in this project. So the first design pattern used here is the adapter design pattern. The adapter design pattern was used to read a list of addresses from the Excel file, as we have seen. Reading addresses from different applications require unique processes and file locations. The adapter pattern provides a common interface to get a list of all addresses from various file sources if desired. And for this project, only the adapter to read from an Excel file has been created. However, the ability to expand the function to read from different applications is available, and to implement it is relatively easily with the adapter pattern. So talking a little bit more detail about that. So here again is addresses.cs, and here we're using the adapter pattern. So here is our actual product, product that the client will interface to get the list of addresses. Here we have our actual adaptee. In our adaptee, we just have um, one method here that basically returns the string location of the address files that we want to read from. And here we have the actual Excel adapter that inherits from the addresses class. The constructor creates a list of string to add that addresses to, and also creates a new adaptee that we can access and instantiates that. Here in the get addresses method here, we return the list of strings that and this is override, this is inherited from the actual addresses product class here to return the list of strings here. And then here, again, like I've talked about before, we actually interact with the Excel file, and we actually read the addresses here from the Excel file. Here we get the Excel file path location from the adaptee here. And then here we traverse through that web or worksheet here to find if there are valid data here to get the actual Excel file addresses. And then again, we add the addresses to our list of strings here. And at the end, we return the strings. And the reason why the adapter pattern here is used is because if you did want to, let's say, read addresses from a text file, we could easily just add in a text file adaptee and have the file location for the text file adaptee. And then the actual adapter, we would have the methods here to actually read the text file, to actually read the addresses from the text file, which is completely different from the Excel file methods of reading the addresses. Going back to presentation, the second design pattern that was used here is a singleton design pattern. The singleton design pattern was used twice to access a web API called Melissa to get the carrier routes and total deliveries in the carrier routes. This pattern ensures only one instance of the class exists at any given time, which is a desired behavior as we only want to access the web API one at a time and to make sure the responses are received in the correct order. When the button is clicked to run the program, the first and only instance of the class is returned to perform the necessary functions. So I guess I should have mentioned before also, when the get address button is clicked here, input Excel addresses when it's clicked. This is where we actually command the program to get the list of addresses here. So here we're creating a new um, instance of the Excel adapter here, and then we actually get the addresses here. And then here we traverse to make sure that everything is okay. So in the singleton pattern, when we actually have a button, when the run program button is clicked here, we run the program asynchronously, which awaits and gets the route carrier and also gets the total deliveries here, and they're both displayed to the data list in the GUI. And here we pass through the list of addresses. So going back here to the route carrier, where singleton is used, there's only one class here called route carrier. And up here we do oh yeah, sorry, right here we do create um, an instance, and then in the instance method here, we do check if the instance is null. If the instance is null, then we return a new object, else we return the same object here. And every time we want to create a new route carrier object, we have to call this instance, as the constructor here is private. So the result of this is only one instance of the route carrier class at one time. And so when we have that one instance, when we access the main function here, which is the get route carrier async, we parse the address, we get the address, um, and then once we're done making a request and creating a request and getting a request and parsing a request into JSON, then we actually add the route carrier to the list here for the object. And this is repeated for how many ever counts or listed addresses are in this string of addresses. And again, this is needed because we do not want to keep calling or keep creating objects uh, to get the route carriers. We only want to have one object to access the API and get the route carriers here. The same thing is implemented for the total deliveries here. The constructor here is private, and here we have our instance method, which determines if that instance is null, then we return a new object, else return the same object of that instance. Again, the same thing happens here in our getTotalDelivery async class, where we repeat this for the amount of addresses or the amount of carrier routes in this case. Once we're done making our request here, actually make the request, parsing the request, then we traverse through the whole request to find the actual carrier route here, and then we actually want to find the total deliveries in that carrier route, and then we add that to the total deliveries list here. And so those are both the singleton design pattern implementations. Going back to the presentation here. The next design pattern that was used, the third and final one, is the builder design pattern. The builder design pattern was used to generate the two different required reports. The pattern was chosen as the construction process of the two reports are identical. However, they require different information in each. Each report has two headers, two columns of data, and a file path to save the generated report. All this data here is completely different, but the construction remains the same, which allows us to use the builder design pattern to our advantage. So here in the report.cs file, this is where we're actually building reports, and we have multiple classes to actually build the report. Here's our product class for the actual report itself. And in here, we set the main header um, for the object. So the object gives us the header that we want, and then we set the main header. Same thing with the subheaders. Same thing with the file path. And here's the actual method to actually create the report, which is the exact same for both reports here. We just have two lists of two data. We just have two data lists here. Here we are accessing the Excel application, and here we are actually creating the report here. We write the headers here, and here we traverse through the two lists here to write the data in the two columns here. And then this line here, we save the file in the file path that's generated or determined by the object here that's accessing this product. Here's our abstract builder class. Here we have two or three lists here, one for the addresses, the routes, and the totals. And these three lists here, this is the three different unique datas that are used in each of the reports here. And then here we have our abstract functions here to generate the report, set the main header, set the subheader, and set the file path. So here's an example of a concrete builder for the Excel report 1, which inherits from the report builder. Here in the constructor, we create our actual instance of the object and assign it to our variable here. And then here we override and create the actual instance of the methods here. So here we just call the set header main, and we set the actual header that we want it to, set the subheader, and set the file path where we want to save the file and what we want that report to be called. And here we just generate the report and pass through the required data for that report, which is in this case for report 1 is the addresses and the routes. Here's a concrete builder for the report 2, which follows the same thing. Here's our constructor, and here we set the actual main header for the report 2. We set the subheader for report 2, And then here we set the file path that we want to save the report to in. And here we generate again the report to for the data that we need, which is only the routes and the totals. And then here is the director, which directs the construction process of the report. So first we want to set the header, set the subheaders, set the file path, and then actually build the report. I guess this is not needed there. Going here, so when we click on the generate the report button one, here we create our director, and here we create our concrete builder, and here we just set the correct data to the concrete builder that we've been working with the whole program, and here we call the director to actually construct the report. And this is repeated also for the report number 2. Again, the director, concrete builder, setting the data, calling the constructor or the director to actually construct the report, and the actual report is constructed, as we've seen. Going back to the presentation, um, I guess we did talk about the design pattern implementation, and I believe that is it that I want to talk about for the report. Thank you for listening, and I hope you have a great day. Thank you.